In this video, we're going to discuss the change of base formula for calculating a logarithm using your calculator, regardless of the base of the logarithm. Your calculators come programmed with two bases, base 10, which is the common logarithm, and base e, which is the natural logarithm. But what if you want to approximate a logarithm with a different base? This is where the change of base formula becomes helpful. According to the change of base formula, a logarithm with base b of an argument m is exactly equal to the logarithm base a of the argument m divided by logarithm base a of the original base b. A could be any allowable base. So when it comes to using our calculators, it would make sense that we would let a be a 10, so using logarithms base 10, which are the common logarithms, or using a base of e for a natural logarithm. In the following example, we want to approximate the logarithm base 7 of the argument 0.8. There are two ways that we can do this. We can write this as the common logarithm, or logarithm base 10 of 0.8, divided by the common logarithm of 7. Or we can also write this as the natural logarithm of 0.8 divided by the natural logarithm of 7. In either case, you can use a scientific calculator or a traditional calculator from your smartphone to approximate the logarithm base 7 of 0.8 using the above. So I have my cell phone calculator with me here on the side, and when I type in the common logarithm of 0.8, I get a pretty long decimal for the numerator. I get negative 0.096910013008056. That's how far my calculator will go. But I think these 5 decimal places will be sufficient for the purposes of this example. Next, if I find the common logarithm of 7, I will get approximately 0.84598. So if I go to 2 decimal places, let's just take that out to 1, 0. So if I divide these two, then let's see what that would give me. 0.09691 divided by 10. So I'm getting approximately negative 0.11467. Now, let's practice using the second interpretation where we're using natural logarithms. So the natural logarithm of 0.8 gives me approximately negative, forgot my decimal point here, let me go back, negative 0.22314 if we take that out to 5 decimal places. And then the natural logarithm of 7 is approximately 1.94591. And if I take this to the calculator and divide, let's see, 591. Well, what do you know? We get exactly the same approximation, 0.11467. So even though the intermediate step may look a little different, the result is actually going to be exactly the same to a certain degree, right? We went out to 5 decimal places. If we were to go out many, many more decimal places, then we may start seeing some differences. But you can see how the change of base formula allows you to approximate a logarithm of any allowable base, even though our calculators only come pre-programmed with base 10 and base e.